Hello friends, welcome to my Pessimistic Guide to Anti-Aging Research episode 11. Let's state it explicitly. The ultimate purpose of our drive for immortality is not only to retain youthfulness but also to preserve our unique personality with everything it entails, including our talents and idiosyncrasies, memories and acquired skills, ways of thinking, etc., for as long as possible. People are generally happy with themselves regardless of IQ and disposition. Now imagine that this fundamental requirement is violated or not met by the proposed anti-aging interventions. The result would be a rejuvenated body without our personality we so crave to preserve. If it is only our body we're concerned with, there is already a much better and all-embracing solution, which is virtually devoid of downsides: cloning, creation of a brand new perfect replica. It is also the most expensive and ethically questionable solution, at least for now. The beauty of cloning is in that it allows us to remain ignorant about the mechanisms of aging. We just replace a worn-out unit by a new one. The technology is already available, and we, or rather those who can afford it, can have genetically identical and perfectly young bodies, and perhaps even similarly organized brains, but it is not going to be us, our memories, just our copies without the legacy of previous lifetimes. So, what is the point? We seem to already solve the biological part of the riddle as far as a body is concerned. Ethical limitations can, and, if I may add, will be bypassed sooner or later if needed, but it is the remaining part, let's call it legacy or a continuation of our original selves, that we're going to have difficulties with. In part, it is a question of time frames afforded by different mechanisms of aging in different organs and systems. So, let's check out the time frame afforded by our brain. I will use one of the few longitudinal studies available today. The cardiovascular health study / cognition study in Pittsburgh followed 914 dementia-free individuals with mean age of 73 for more than 20 years. During this period of monitoring, 492 or 63% of participants developed dementia. At the end of the study, 160 participants were still alive, but only 19 individuals, or 12% of survivors, were free of dementia. I should note that, among other things, highly educated people seem to be more resistant. This can probably be explained by a consistent stimulation of adult neurogenesis. So, it seems reasonable to conclude that the lifespan of our brain is roughly synchronized with the lifespan potential of the rest of our body. There is no significant time gap, and this means that any interventions concerning a separate organ or system, like organ replacement, regeneration, while valuable as a medical procedure improving quality of life, will have very limited meaning in terms of increasing average dementia-free lifespan. From this perspective, even stem cell therapy is not going to make a cut as a true anti-aging intervention for humans. We might be able to replace neurons responsible for generic functions such as emotion or endocrine control, but we cannot replace those that function as a seat of our memories. And this defeats the purpose, for the only form of the second life worth pursuing is the one with undamaged original mind and a full complement of memories. There are two options to consider. Since the aging-associated damage to some of our brain cells seem to be irreparable, the most natural approach would be to find a way to delay or prevent loss and deterioration of neurons starting as early as possible. For this purpose, we will have to target the mechanisms responsible for cell loss, which still appear to be not identified. How strange is that? The second, and rather outlandish option, is to learn how our memories are encrypted, and whether it is possible to record and transfer these memories to a new brain of a fresh clone. This challenge is worthy of the outsized ego and hence enormous desire to live forever of Elon Musk. With his resources, he probably can pull it off, but it will require perhaps 15-20 years of intense effort and lots of money. Also, the clone or clones need to go to maturity, say about 15-20 years. Although the traditional biology seems to be quietly degenerating into a second fiddle to in silico science and big data, we will stick with it for the time being. There have been several attempts to delay and prevent dementia, and so far none of them was successful. To continue this conversation, I need to make sure that we share the same understanding. All the time, I hear or read about someone declaring a war on diseases of old age, or calling aging itself a disease, which in my opinion is grotesquely wrong. It is mostly semantics, of course, but I still think it is important to know where we stand because it dictates our strategies. The way I see it, disease is an illness caused by some violent event in otherwise normal, young organism. It can be infection, trauma, or an unfortunate inheritance of mutations that cause organ or system-specific failures. It can be anything really, but on the background of otherwise healthy and fully functional organism. With disease, one can count on isolating a responsible agent, a specific mutation or event. In contrast, the application of the disease mentality to aging-associated conditions is less than useless. The aging is a deterioration of all cells, organs, and systems. The diseases of aging are simply local symptoms of the global process of decay. They may appear superficially similar to diseases of young age. After all manifestations of organ dysfunction are largely identical. But the background is fundamentally different because everything is compromised through multiple mechanisms and in many diverse ways. There is simply no single cause in a conventional sense. So, to be effective, any intervention should address a true contributor to brain's aging, whether systemic or local. Unfortunately, for decades now, there were only two hypotheses dominating the field: the amyloid cascade hypothesis and tau phosphorylation hypothesis. There are several excellent reviews on this topic, but to me, the most important thing is that virtually all clinical trials based on this hypothesis fail. A quarter of a century-long effort that produced nothing. On top of many other lines of evidence, this proves that infamous senile plaques and neurofibrillary tangles are not the cause of brain aging, but a mere consequence of it. If it is so, here's a question. Will devising more efficient ways for cleaning blood stains from the crime scene reduce homicide rates? Yeah, you can ponder it if you want, but one thing is clear. Our brain needs attention. As for myself, for my brain's sake, I'm going to call it a day. See you next time.